Ladies and gentlemen, welcome back to the live demonstration area. We are pleased to welcome back Roctool. Roctool are going to give us another highly innovative demonstration and highlight their innovative molding processes such as heated platens, which are showcasing a mix of high performance and energy savings. Please give a very warm welcome to Mathieu, Boulanger, the CEO, and Edouard, PHILLIPE, the Composite Business Development Manager of Roctool. Gentlemen, the demonstration floor is yours.
Thank you, Joanna.
Thank you.
Good afternoon, everybody. Can you hear me okay from there? Yes, all good? All right. So my name is Matt. Edouard is here. We'll spend about half an hour together. Maybe 25 minutes, then we'll have question and answers. Hopefully we'll have the answers. I know you'll have the questions. But we're here to talk to you about Roctool. So we're a heat and cool provider. We've been in the industry for quite some time. And this year we come up with a new approach. We've been heating and cooling molds for many, many years, which is how to integrate induction technology within a mold and have the ability to go from one temperature to another, and then have a secondary network with water cool and cool down and demold your part. And we realized that in the industry, there are many manufacturers, they need to have a heat platen that has maybe more than the everyday heat platen that you can have with oil or electrical cartridges. But here, the ability to have the induction integrated in a way that you can, in a dynamic way, control your heating and your cooling within the platen and have an insert with a cooling network also on top of your platen, so that you can swap your inserts, aluminum-based or steel-based, as you wish. So we're going to do some molding sessions. Here with me, Edouard has a variety of reinforcements. When we prepared the show, we were like, what do we want to show? Because what are we going to mold? And we wanted to show that the ability to control temperature actually allow you to go from one material to the other. So this year, we have selected some material manufacturers, and Edouard will introduce for that demonstration two material providers gave us some materials, some of their different reinforcements. And Edouard, can you tell us what the demonstration will demonstrate?
Yes, thank you, Matt, for this introduction. For this second demo, because we start at 10 o'clock. So you hear me? This is clear?
Better.
Okay. So we will have two different materials for this demo. One is supplied by Rainbow Company. It's a Chinese company. We use unidirectional prepreg material with polyamide, which is thermoplastic resin. And the second is from your company. It's Ayate material. It's a non-woven recycled carbon fibers. And during these 30 minutes, we will have the opportunity to show you this demo with these two materials.
Exactly. So the point of the Roctool technology is the ability to heat all the way to a consolidation temperature, have the ability to hold or to dwell, and keep enough heat in the platen to be ready for the next cycle. So obviously here, we're not in a production environment. We did our best to come up with our truck and our machines and simulate the production, but understand that the advantage of the platen is this ability to quickly go from one temperature to another. And then the insert by heat transfer will be heated so that the composite can be fully consolidated. But then we're going to cool down the insert, cool down the platen at the same time, but we can keep a transition temperature on the platen so that the next cycle we're ready to just reboost by induction. So the full power is used during the heating of the platen. And then in between the cycles, we can just dwell the platen, so very low energy consumption. And that becomes interesting because if you compare oil heaters, where you need a lot of capability to heat with not necessarily the best results, especially if you start going higher heat, 200, 300, or 400 Celsius, you start having some difficulties. And then if you look at electrical heaters that are not that flexible, here you have, with the induction heating, the ability to reach high heat fast, and you can dwell, and you can go from one cycle to the other. But here's another advantage. Let's say that you have your production and everything's hot. You know, you've got like oven, you have oil heaters, you have hot press. typically it takes some time before production to heat up everything. Then you do your production, and many manufacturers, they don't turn off when production's finished. They just leave it on for the next day because it would take too much time to reheat everything. Here, it's not the case. So think about the energy savings that could be done if you have a lean technology like that in between cycles. So before we start, let me introduce Hugo, who's over there by the remote control. So if we look at what do we see over there, and you can look on the screen, let's maybe take a look over there. We have a compression press machine. We have 2 platen, one on the top side, one in the bottom. Each of the platen have a heated network, 50 kilowatts per side. We have an induction generator and our cooling units, which is water ambient temperature here at the show. So that's it. So maybe we can start, Edouard.
Yeah, we can start with the first demo. So for this first demo, we have a shoe sole mold in aluminum that we heat with our IDS system. So we put the material on the surface of the mold. The material is, as I explained, supplied by Rainbow company. It's a pre-preg material with polyamide resin with different layers. So we can show you, yes. We have unidirectional carbon fibers. And on the skin, we have a weave of carbon fibers for the look.
So this is nylon. The point here is, as you can see throughout the whole show, we're going to play with different resins, different reinforcements, just demonstrating that once you control temperature really well, well, then it's easier. So here it's a nylon, and we will bring the platen to, I think, 270 Celsius, and the insert, the surface of the insert will reach 250. 230. Okay, 230 C on the insert to get a resin-rich surface and a full consolidation. So a few words about induction. Induction is a safe technology. It's used in many industries. Recently, we have one of our new partner, the NREX group that joined Roctool, joined forces, has 30 years plus experience in the world of induction for heat treatment, welding, brazing. They use it in so many industries. What we do is we focus on how can we use induction for molding, and how can we use it in a way that is versatile, in a way that allow you to have this flexibility as you're manufacturing thermoplastic, but it's also applicable to thermoset. Because with that heat platen, we could definitely do program of holding and dwelling and curing. However, for the show, we did focus on thermoplastic solutions.
So we start to heat now, and we reach now in less than a few minutes already 200 degrees inside the heat platen. So for this installation, we use the generators. It's a dual zone generators with a capability of full power of 100 kilowatt. We use 50 kilowatt per side, and also the interest is to manage separately the power on the top and the bottom, if the mold are quite different in case of
exactly.
design.
And when we say 100 kilowatts, so you use 100 kilowatts to heat up. Then people are, oh, that's a lot of energy, but just think about it. That's one we heat up. As you reach your temperature, and then when you start dwelling in between cycle, when you have your heat platen, let's say that you want to keep your platen 150 C, okay, your insert has been cooled down and you're ready for the next cycle. The dwell consumption is 5 to 10 kilowatts as we dwell and maintain. And 150 C or 200 C would be the same exact thing because it's just about keeping hot the platen. That becomes interesting. Then you're in a very dynamic, that's why we call it RIDS, Roctool Induction Dynamic Saver, because we're going to save energy in between cycle or when we're done in the cooling phase. Same thing, you're finished with manufacturing, let's say the production day, no need to keep everything hot at nighttime, because in the morning, the induction being so efficient, you can get back to your temperature quite fast. So here at the show, we have 2 heat platens and we're heating inserts, and we're doing that here in 5 minutes per part. So in the past, integrating the induction within the tool, we can go even faster. But again, the ability to have the heat platen makes a more cost-effective way, because the aluminum inserts can be fairly low cost, and you have your base heating, which is a one-time investment. So that's interesting.
So now, in less than 2 minutes and 40 seconds, we reach a maximum of temperature to melt the polyamide of the material at less than 300 degrees. And now we start a step to stabilize the temperature during 1 minute before to start the cooling. So we have now again 20 seconds before the cooling and before the demolding. So it's very quick. With this configuration, we can have a heating rep up to 55 degrees per minute.
Yeah, exactly. And we do size, we recently did a project of 2.5 meter by 1.5 meter. So here at the show, obviously already doing all this investment for the demonstration, we're not going to come up with a 2.5 meter panel, but it's sufficient to demonstrate what the technology can do. And the generators, as Edouard was saying, I don't know if you did catch this, but we have dual zone generators. So we can have one power unit that heat the core and the cavity separately. But we also have one generator that can have two zones, which on the same panel, if needed. So that's also something to keep in mind.
So now we are on the cooling stage. So for this step, we use a dedicated Roctool equipment. We have here a C6 cooling unit with the capability to deliver 100 liters per minute at 20 degrees. So we can reach during the cooling a ramp down around also 60 degrees per minute in this configuration again. So we reach less than 200 degrees at this moment, and we make a crash cooling to before demolding. In fact, next to the C6 equipment, we have also another device which is a W18 equipment. It's a cooling unit also connected for the generators because in this configuration we have water-cooled generators, and we need to use also a dedicated equipment for that, which is a W18.
So Roctool as a technology, we provide engineering services. It means anybody coming with a part or a dimension for a platen or a level of temperature that has to be reached, we receive the data and then we come back with a proposal and saying, this is what we could design for the induction and for the cooling. Because everybody has different parts or materials or temperature levels. Know that the induction can go, and we do mold peak or PEC, and we can go 400 plus. Then based on the level of temperature, we would engineer differently. Obviously, if we just need to go to 200, the type of platen and the type of power unit that is needed and the inductors that we would use would be differently than if we need to go to 300 or 400 or plus.
So now, Matt, we are ready to open the press and demold the parts. So we demold at 140 degrees with this material, and we can directly obtain the part after consolidation.
The platen remains 140 degrees. The insert is at 80, 70.
80?
Yeah.
That's all. So you have the final surface quality, which is also very gloss.
So we can see, obviously, the material where we're not heating on the edge, and we can see the fully consolidated resin-rich surface in about 5 minutes here at the show. So the thing also about thermoplastic, it's all about temperature distribution. And with our engineering, we have a 2D, 3D simulation before we do any molds or any heat platen. We can simulate the ramp-up of heating, how many kilowatts you need to get to what temperature, and what is the temperature distribution. So that's for that particular part here, supplied by Rainbow Materials. So on the second demonstration, it's going to be a little bit different.
Yeah, we would like to show you a very different material, of course, dedicated for thermoplastic composite application. And so it's why we selected also Ayate material supplied by Yuo company. It's a Japanese company in the Toyobo group. They produce recycled carbon fibers with a non-woven mixed with thermoplastic resin. So basically, for this live demo, we use polypropylene resin. So you see the raw material. So for this demo, we use 5 ply of non-woven material, and we can install it, lay up on the press now. Yeah.
So one thing also about this, the ability to handle material in a cold tool at the start of a cycle. That's also quite interesting because in a production environment, talking about safety, talking about the ability to maneuver materials in a pre-impregnated version where you don't have to start from a fully consolidated plaque that would have to go through preheating and then would have to be transferred. Here we're using only pre-impregnated materials as the initial format. There's some other demonstrations tomorrow with chopped carbon, where we're going to just pour the amount of chopped carbon that is needed for the part. And there's also another demonstration later today where we do 3D textile, so 3D knitted composite from Saint-Gobain that actually give you like a one-shot. So we're doing this. Here, this material from Hayate shows that you can use recycled carbon. It's very flexible because of the non-woven, so very easy to place in the tool. And then with the induction heat, the resin is going to migrate to the surface and get the full consolidation.
We can start the second cycle, Matt?
Oh, yeah. I thought that was going.
So just push on the button and all the programmation of the cycle start. So sometimes we can start also with a purge step to do not have water inside the mold before to heat. And now you see that on your screen, you have a red pin which explains that we are in heating stage. So we start the heating up to 220 degrees due to the range of the thermoplastic resin, which is polypropylene.
In terms of heat control, based on your process, we can define with the customer where we want to have thermocouples. So there are thermocouples within the heat plate, obviously, but we can also have thermocouples within the inserts to make sure that the temperature is reached at the material contact and not, sometimes we see like oil heaters or electrical cartridge giving us temperature information on the device, but do we really know that within the material we have the right amount of temperature? So that thermocouple that is directly on the remote control give us this live information, and then you can program your cycle, and that can be automatic for the heating, the hold, and the cooling.
Yeah, just also some complementarity information about the Hayate material. It's very interesting also for the droppability because we use a non-woven material, and in the case of we need to mold the 3D geometry parts, we can easily lay up the material before the heating and to consolidate a 3D geometry part in just a few minutes. So now we reached 230 minutes. You see in a few minutes.
So from the previous cycle, if we did that 2 minutes, because the first cycle, if you remember, that was 3 to 4 minutes, is because of this dwell that we talked about, where the heated platen remained at a transition temperature, but the insert was fully cooled down to 70 C. That allowed us to quickly do another molding and to keep going like that, still being at 70 C on the molding surface. So talking about cooling, here with the cooling capability that we have at the show, we could go even beyond if we were in the factory with maybe more capabilities. But it's sufficient to keep a 5 to 6 minute cycle even during a trade show.
Now on the screen, we have a holding time ago. That's yeah, we have in this cycle a holding time of 1 minute, just to have the time for the temperature to go inside the material and to have a good impregnation of all the fibers and the resin during the consolidation and with the pressure applied by the press machine.
Maybe just a few words, as this is just a visual of induction integrated within a mold or within a platen, because a heat platen is a mold in a way. You can clearly see the network of inductor that is within the tool and a back network of cooling. And we play with that fully integrated within the mold. So We do 2D, 3D thermal analysis, so we're able to simulate before making a heat platen or before making a mold based on your part or your requirements. We can do a study to show you how the heating would be distributed and how much power is needed, what will be the cycle time. We have the software to simulate all this before actually cutting steel, before making the mold, which is always interesting as we build a business case and to compare versus maybe more conventional heating. Does it make sense to switch to induction, or should I remain with whatever conventional methods that I have? In terms of safety, induction is very safe. It's fully insulated. It means that our inductors within the mold are insulated. We have a variety of techniques. We also have inductors that are cooled down within the tool. And it's safe, like we don't have any electromagnetic field going on the mold. Like if I touch the tool or the platen, I would just get burned because it's hot when it's 250 C, but I'm not going to get electrocuted or anything because the induction is within and embedded within the tool and within the heat platen.
Just also for your information, we will have another demo for this afternoon and tomorrow also. For the next demo, we will have the pleasure also to use different other material. Another one for 3D preform textile come from Saint-Gobain Aerospace Company. So this afternoon and tomorrow morning. And also, we will have another selected material with Waste Saver Company to use also different natural fibers and carbon and glass fibers thermoplastic semi-finished product.
I think we're ready to demold, so let's go.
Yeah, no.
So on this kind of thermoplastic materials, we also have, in our cases, a combination of multiple layers. We could trap non-woven within UD. So for instance, if you have like a unidirectional layer and multiple layers of non-woven and another layer of UD, we can encapsulate and consolidate all and different material layers. So this is what we have.
Okay. So good, we'll have the finished part.
And again, I love this because I'm not going to touch this that much because I did that yesterday. It was bad. You can really see the clear heat pattern where it's consolidated, and all the material that is not consolidated around it where we're not heating. And you can see the consolidation and the resin-rich surface where there's no more fibers on the surface. It's only the resin, which in this case, it's polypropylene, right?
Yes, exactly.
Yes. So I think we can take questions because we have 7 minutes left, and we'd be happy to answer any questions you have, or at least try to answer them if there's any.
Don't hesitate.
So in terms of uniformity, based on the analysis we do, and then in the reality, based on each material and so on, or how fast you're going to heat and so on, in general, we can get to plus or minus 10 Celsius. We have projects where it's required to get plus or minus 5 Celsius, and then it's all about the heat pattern, making sure we catch this with the thermocouples, but we're within this range.
And when you do it on a longer, bigger molds of 2.5 meter by 1.5 meter,
yeah, same.
Do you do the average of the temperature at different places, or is it one place where you read the temperature from?
No, we heat the whole thing. We heat the whole...
The sensing of temperature is done at multiple points?
Multiple points. And then we have a monitoring of all the thermocouples, making sure that if there's a section that catch up the other one, I mean, we monitor that. But obviously, when it's large surface, we have more thermocouples and to monitor temperature distribution.
Any other questions?
Yes.
Matt, what is the energy savings that you bring to a normal, to a producer in comparison to a normal process?
Okay, so on this little leaflet, we're showing some cases where it could be a ratio to 2 to 3 or more when we compare to electrical cartridges or oil heaters. Obviously, I mean, that's an easy win. However, it's tough to just give you like one data. We could give examples because the bigger the surface is, the more dramatic the energy saving will become, obviously. So, and it's also about the cycle time. If it's a part that require a very long holding time, if it's a production environment where we know that a lot of the heaters remain in place as you're not manufacturing, then it becomes more dramatic as we go. So it's hard to give you just a one answer saying, hey, we save 25% of energy, because that would be a lie, and everybody knows that. The point is to say, per case, we will demonstrate how induction can outperform conventional heating method. There's no debate. Then the point is, what's the business case? What's the investment versus the part I'm making, and how many parts I'm making? Am I going to reduce scrap? Am I going to reduce some of my operating time and my energy consumption? So that business case, we're ready to do it with every customer to build the induction system they need for their own application.
Any other questions?
Nope.
I have a question for you, Mathieu. Can you explain why you chose this particular demonstration?
I think we picked that demonstration, and especially this new heat platen, to be able to do 5 different materials during the show. I think a lot of process that we see out there or technologies, they're going to be focused on like a one case, one material. We want to show that the induction is very versatile. Some of the demonstration is 180C, some other demonstration is 270C, different reinforcement, different thickness. Some of the demonstration we have upcoming, we're going to show a 3D knitted composite, which is the ultimate preform, right? Where you put that in the tool, and you have, you don't even need to drape or to, it's just like a sock, right? And you put this in your mold, you heat up, you cool down, you remove your part. It's a net shape, 0 waste. And then we're going to switch to chopped carbon to show that this comes from recycling carbon and how you can mold it. So I think we picked this just to show in 3 days how far just having good heating allow you to play with composites and make it as a more lean manufacturing.
Okay, thank you so much for this answer. Thank you very much, gentlemen, for your demonstration. Roctool will be back again today at 4:15 for another demonstration. Otherwise, don't hesitate to visit them at their stand. They are right next door. It's very practical. Ladies and gentlemen, this concludes our live demonstrations for this morning, but we will be back at 2 o'clock with Thermwood, who are going to show us why their large-scale additive manufacturing machine is a game changer in additive manufacturing. Don't hesitate to come back and join us at 2 o'clock. Otherwise, bon appetit, enjoy your lunch, and enjoy the rest of the day at the Jack
Thank you for coming.
Thank you, Roctool.
Thank you.
Thank you.